Okay, guys, let me start with a very basic presentation. Actually, I designed it just to give you an idea that how these bar graphs work. So here we are. Uh, Something about the anatomy of the bar graphs. What I have something like this, as you can see on the left, right here. User input minimum value. These things are necessary for every type of bar graph. User minimum input, user maximum input, maybe they are votes, any kind of a score or stock data, whatever. I have the percentage calculated on the basis of minimum and maximum, which is the very basic primary percentage formula, minimum divided by maximum multiplied by 100. And I also add a feature by which you can increase or adjust the height of the maximum height of the bar graph. So maybe you want small bar graphs in front of, on top of the table in front of your talent, or maybe you want a larger bar graph, larger than life, behind your talent. So the height is absolutely customized. The last thing that I add is this pointer. It is always pinned on top of the bar graph, no matter whatever the height will be. So these are some basic steps that you can see that how I design the logic blueprint or everything for these things. The next is the logic breakup. I will give you a very basic example. Let's say if you have the minimum user input is 500 out of 1000. Bar scale that you set, what the bar scale, let me tell you. I am talking about this maximum height of the bar, right? So the bar scale is 2. Bar current value that you will get is 1 on the basis of these two minimum maximum value. Am I right? Yes, absolutely right. Because half of the 2 is 1 and the percentage will be 50%. In terms of blueprint, what I have a timeline starting from 0 to 1, and I'm using this timeline for almost everything. I just give input, minimum input to the lerp function, which maps 0 to 1 to 0 to 500 and gives me the output of 500 to my function, which is map range clamp. And what it does, it just gives you the accurate length of the bar, because the scale is customized. There is no fixed value of the scale, so we need to clamp the value so we will get the exact height of the graph, and it will put right here on the z axis of the relative scale 3D of my bar. This is my static mesh, the bar that I'm using. Another example, if you have user input 3500, user input maximum is 8000. You set the bar scale 1.3. What happened? The bar scale will be 0.56 on the basis of these two values, and the percentage will be 44%. Again, 3500 goes right here, gives you animated output 0 to 3500. 8000 in range B, I have 0 to 8000, and 1.3, 0 to 1.3, I have the output range. So I will get the accurate scale of 0.56, and I put it right there. So my bar scale will be 0.56 and the percentage will be 44%. Another thing that I did, I use a scaling method to animate my bars. You can use the position or whatever you want, but right now I am scaling the bar graph according to your requirement, your input values. to pin my percentage pointer exactly on top of it, I am calculating the bounding box. I am calculating this bounding box, this box extent of my static mesh right here. And I'm multiplying it by 2 because if I didn't do anything with the origin, the default origin is 0.5. So when I multiply 0.5 by 2, I will get 1, which is right here. So when I put my widget percent, which is the widget graph, which is the percentage graphics on top of it, and I will always get the right value, which is right here. Whatever the scale will be, the percentage will always be on top. And I also add my public variable here, so you can change it according to your requirement. Not only on the top, you can place it in front of your bar also. Let's get into it practically. If you don't understand, no problem at all. I have a very basic scene because this is kind of an AR graphic, so I don't need any kind of backdrop here. What I have is a very basic, nothing fancy, a percentage graphics, right? This one. And if you don't know anything about UMG Widget Blueprint, please refer to my second webinar, I think, right? Okay, I've already discussed about it in detail. So what I have a timeline. I animate basic graphics right here and just put the text 100, which is not the permanent text that you can change it in real time. And I bind my function with this variable percent number. I will communicate with this variable and give it my input in real time when I'm working on my bar graph in another blueprint, which is the master blueprint. What I have next, I have another graphic, which is minimum maximum graphic. Let me show you what I have. Again, very basic, very simple. This is my minimum, this will be my minimum value, and this will be my maximum value, right? Again, I bind it with function. Text minimum is my desired variable that I want to have in my blueprint, and the text maximum is right here, as you can see. So let's get into it. Create an actor blueprint. My webinar graph. First thing first, let me show you what I have. I've just designed a very basic geometry in 3D Studio Max, like this. And whatever you import as a custom mesh in Unreal, you always get the scale value 1, 1, 1 on XY. So it is there. And let me show you one thing. Here we go, the bounding boxes. So let me put my static mesh right here. So add the component static mesh right here. I've already selected it, so I don't have to browse it right from there. And I also want to give it some basic materials like this. Let me show you my material. It's very basic. You see, just single color multiplied with a kind of gradient, and that's it, nothing else. So what else? Let me rename it SM bar. I'm going to duplicate it in order to make another mesh component, which will be my base. And what I'm going to do right here is scale it down a bit. X 1.2, 1.2. I would like to change the material. Just change it with this one. And here we go. My bar and my base. Let me set it. Because it is overlapping with the base, let me select my bar and something like this. Okay, what else? I need my percentage and I need my minimum maximum values right here. Okay, so let me do one thing before I get them there. Just to get the reference, because when I get it in my blueprint, I can't see them. Just to get proper reference, I'm just going to make it visible. Sorry. All right, and this is quite a big graphic because it's 256 by 256, which is something around, which looks quite big in blueprint. So how you get UMG or widget blueprint inside the class blueprint, actor blueprint? Add widget component, name it widget percent, and I'm going to select my VP percent right from there. Look at that, how big it is. No problem. Make it the draw size accurately, and I'm going to scale it down. Put it right there. I think a bit more. Like this. Sorry. The position doesn't matter at all. But one thing is very important. I will show you when I move it in any direction, my viewport is not drawing it, right? So there is an option. Sometimes it creates problem in real time also. So there is an option which is pick off a screen. Just check it, search for it, and check it. Now you see, it worked perfectly. Again, add another widget. Sorry. Name it widget min max. Let me search for it. Here we go. Scale it down. Something like this. And I'm going to put it 90 by 90 right there. Maybe off the ground 0.5. Don't forget to add Z reactor. Now I am just drag it out and put it right there on wherever you want. I mean, just 0, 0. It's there. And you see what happened with the minimum maximum graphic? It disappeared because it's off screen. Whenever it is near to off screen, it always tick when off. Okay, guys. Now let me hide them again. I don't want to see them. And just move. Where is my transform here? Just outside the bound, outside the canvas. And now this one. Sorry. Yeah, this one. Move it. Okay, so let's start blueprinting. First, I need to create some variables. Definitely, user want to input the minimum value. So user min is my first variable. Integer this time. Another variable is user max. And other thing that you want to set is the graph height, right? So graph max scale, and it must float. And what else? Yeah, pointer location. You want to set X, Y, Z, the person pointer location wherever you want. So pointer LOC. And make it, because I want X, Y, Z, make it vector. More or less, these four variables work for me. Okay, my pointer LOC, graph maximum scale, user maximum value, user minimum value, and let's create some functions here. I love to work with the functions because I don't want to create a mass. I can do in the event graph also without the functions, but it creates mass and you can't understand what's going on there. So let's divide your logic into different functions. First, I create a function to get minimum and maximum values from bp underscore min max. Okay, so set min max. This is my first function. Before that, if you want to get the values from this widget, okay, what you want to do is, it is right there, sorry, this one, right there. Okay, let me create a macro for it because it's quite handy. I will get all my initialization inside my macro and connect it with my event begin, right? So first, get it. And what I am doing right now is just try to communicate with my bp underscore min max, right? Cast to VP min max. Okay, let's connect it and give it a reference. Save this in a variable so you can use it again and again and again. What it is, widget reference min max. Let's do it for percentage also. That user widget object. And what is casting? I already explained it in my first two webinars. If there is any confusion, you can refer them as well. And what else? Cast to VP percent, I think. Yes, here it is. Connect it. Give it a reference. That's it. One more thing. Maybe if I get time, I will show you how to change the material according to percentage. Maybe when the graph is like 10%, it shows the green color, and when it goes to 90, it changes its color into red or something, whatever. So for this purpose, what I'm going to do, click the easy way. The click on the SM bar, right click, create dynamic material for bar, and sorry, also store it in a variable. What it is bar material reference. Okay guys, it's almost done. So I initialize all my casting and all my variable inside this macro. What I'm going to do, that drag this, let me name it bar init, drag it out, and connect it with event begin play. So when I hit play, it gets the value and is stored inside these variables, right? So quite helpful. I can also put them inside the construction script also, but I don't know. I like this way. Okay. What else? Now I have set minimum and maximum function right here. And I want to create a logic to give input that user can give input to the minimum and maximum number for my graph. So what I'm going to do is get my variable here. If I press control and drag them out, I always have getter, and when I press alt and drag them out, I always get setter. And when I press nothing and drag them out, it asks me that what you want, getter or setter. So I get my material, I get my variables right here. And what I'm going to do is I've already stored my minimum maximum inside this variable widget reference min max. So inside the function, I'm dragging it out right there. And let me check the names. So it is my minimum, it is my maximum, but I need to check my function. Text minimum for the minimum. And what about this? It should be text maximum right here. Okay. So set text minimum. It's there, guys. And I will connect it like this. And again, drag it out and set text maximum. It's already communicating. You see that when I cast and store the variable, store my blueprint inside the variable, I'm getting these variables from my BP min max, right? Set it like this, and you must give it the user maximum value. That's it. I can get the user minimum and user maximum value in real time now. I will show you in a moment how. Now, another thing, as you can see that I have some animations inside my UMGs, my widget blueprint. So I want to trigger them from this blueprint. This is something like my master blueprint, right? So what I'm going to do, I'm going to create an other function, one for reverse and one for forward. For the sake of simplicity, I can do this in a single function also, but to make it simple to understand, easier to understand. So it will be show function and another function which will be hide function, right? Before I start working with the show function, I am going to have a timeline just to show you what I'm going to do. Okay, name it first, bar animation. I'm going to create two custom functions here. One, bar forward to play from start. Another custom function, bar reverse to play from end to reverse the values. Okay, now I got these two events. Let's connect it to my show function, right? Because it's by default all the functions are public in my control application. When I see this button, see this function, I click on it, it triggers the bar forward event, right? Okay, and what else? I need to trigger the animation for the widget also. So get the reference for minimum maximum, this one, and get the reference for percent. Where is my percent? Bar material reference, bar animation, SM. Let me check. Did I do something wrong? Oh, yeah. I didn't store it inside a variable. Sorry. Right click, promote to variable, name it widget ref percent. That's it. So inside how to get the animation, there is a track. You see, bar data nn. I will get it, or you just type nn at the end of the list. You will get your timeline, your track. Play. The target will be my widget. For this one also, get number track. And what is number track? Number track is right here, right there. Okay, which triggers the animation of for my person. Press select and press Ctrl W to duplicate animation, target. That's it. It always play this function, play the whole play event, including my widget for my blueprint, right? So just copy them right here, Control C, and in the height function, first take bar reverse. What is bar reverse? You remember? This one. Okay. In the height function, first get bar reverse and paste it right there. And we have a very handy feature here, which is reverse. That's it. Compile. Now, I have my forward function, I have my reverse function, and everything is there. So let's start animation. Double click on your timeline, add a float track, press shift and click. It adds keyframe, or you can right click also. 0, 0, 1, 1. Okay, and the length should be 1, or you can even check use last keyframe. Zoom extend all, select all of them, right click, make user, and give it a nice curve right there. Okay, so I have my timeline, I have my flow track. The next step will be I am getting my variable as a getter and right click, type learn. Now you remember my presentation, my slide, because it gives me value from 0 to 1, right? Always 0 to 1. So if I connect something like this, my user input will be maybe 1000 or 250. It always learn between 0 to my user minimum, right? And it gives me the animated output of this value from 0 to the user minimum value, maybe 500, 200, whatever. The next step is a little complicated for the newbies, for the beginners, which is range map clamped. Okay, and why I am using this, just wait a moment. Map range. There are two things: map range clamped and unclamped. Both of them have different functionality. I'm using clamped right. So when if I have user input is 500, I have 500, put it right there, and user maximum will be in range B of input, and my graph maximum scale will be in range out B right here. You know what happened? When it gets the 500, it finds 500 between 0 and user maximum value and map it accordingly to this scale from 0 to this scale. You will get the idea when I execute all of this, right? And I'm dragging the reference of my bar scale. What I want to animate this, right? Which is z-axis of my bar, okay? And I can't put the values like 500. No way. It must be reasonable. Maybe one, two, three, four, five, but not like this. So the map range clamp work just fine for these kind of purpose. I am just getting set relative scale 30, and what I am going to do, because I just need the z-axis to be animated by this output, and drag it out, break the vector, okay, and connect it like this. I don't want to change x and y. If you want, you can even create some variables for them also. So, and my timeline, all way after all of these things, my timeline update the scale. Okay, something like this. All right, and one more thing, that set minimum and maximum function should be triggered before everything, right? Right here. Okay, so now it's time to check the graph. What I'm going to do is, I already created a R graph for this. You can also check it in game mode. Uh, it's up to you. My webinar graph is here because of the ZD actor. You see user minimum, user maximum, graph maximum scale is here, and also pointer location. Pointer location, right now pointer location has nothing to do with it because I didn't define the logic for it. So maybe a candidate get something like 15,000 votes. No, maximum voters are 15,000 and he gets 7,500. Okay, you can set the bar scale to double, like 2. If I play my bar, you see what happened? Right now I didn't define anything for the percentage, so you can see 7,500 out of 15,000. Let's change the numbers. You can't see the percentage right now, but you will. 15,000, and he get, fortunately, 15,000. So what is? It is something like this. Height, show, height, show. My graph work absolutely fine. You will get the complete idea when I pin my graphic on top of it, my percentage graphic, right? So let's save it, stop it, and do something for percentage. Okay. So let's create another function. calculate percent. And you already know that the percentage is based on minimum and maximum value. Let's create an expression for it. So for the sake of simplicity, it's a great way. What I'm going to do is set a variable for minimum divided by another variable maximum, close the bracket, multiply by 100, and here we go. I created my expression here. It's a very good way for the complicated, it's not a complicated calculation right now, but it's a good way when you have so many things to calculate. So I have already calculated my percent, and the output will be what? Will be this. this text. So I am getting the reference of my percent widget out of here, and I don't remember the name of the variable. It is percent number. Okay, so I am getting it percent number, setting it, sorry. But before setting, right now I don't want any decimal values. So maybe it's a good idea to truncate just for the integer part, right? And drag it and connect it. Compile, calculate percent, and I think I need to place it somewhere. Anyway, place it right there also at the end of the graph. Let's compile it and check the results. Okay, 15, maybe 7,500 out of 15,000. Bar scale is 2. Let's check what happens. Accurate 50%. I'm good at maths.
You are.
Yeah.
Actually.
Oh my God. It's a very simple calculation. 23%. Right? But it is not following my graph right now. Okay. What I want to do, I will, let's make it like something very bad quality issue. 150 votes out of 15. Yeah, it's okay. Only 1%, around 1%. So what I have, everything works absolutely. Oh, it hides definitely. Everything works absolutely fine. Let's pin it on top of your bar. How I supposed to do it? Oh, let's clean this junk. Okay. So another function. Set pointer location. And what I'm going to do is SN bar, drag it right there, type bound bound, get component bound. And what I did, because it starts from the origin, which is the center, 0.5, I need to multiply it by 2. Okay. And I am going to set it something like, where is my widget, percent widget, right there. Set relative location. I'm going to drag it, break the vector, and add float into float. I think I did a mistake right here. Let's delete it. First, we need to break the vector like this, because I just want to get access of Z axis only, right? So not X, Y, Z. And now I am multiplying it, float into float, give it the value of 2, and. Drag your variable right here. This is my vector variable that initially I created, right? Break it also like this, and add the Z of your variable with this, the z multiplied by 2 of your bound, and you will definitely get the exact top position of the bar where your widget percent always pinned itself. Connect it, but I need to change the values in real time. So let's make most of reality a great feature, which is the function callback, right? Whenever this variable change, it triggers the function automatically. So let's copy the name of this variable, Control C, and I'm going to change it something like this. If you don't know callback events and callback function, watch previous tutorials. No, webinars. On CHANGED, or you can refer the documentation, CP documentation also. On change pointer LOC, compile. Now we need to trigger this event. So I am going to put it in the last of my paragraph, right there. Great. Let's check what happened. Okay, make it bigger. So let's put a random value here, like 50. Oh, works fine. Make it half, a bit more than 25, and it works fine. So what happened? Goes back. You can, by this way, you can pin everything, like even a static mesh or icon or whatever, image of the candidate or image of some sort of weather icon or whatever on top of the, and when I change my maximum height scale, maybe I don't want that no long graph, 1.3 or something, so it fits well. Gives you accurate percent. Let's check it again. 3500. Absolutely fine, except one last thing. I just want to animate these values from 0 to the percent that I have. 0 animated, count, not count down, count up.
Count up.
Yeah, count up kind of. So, and before that, I will show you something. Make it 6500, and okay, I can easily move my, it is working. No, it is not working because I just made a mistake, maybe. Let me correct it. Yeah. Oh, yeah. Save it. On chain. Look at that. Broken link here. Now compile it, and I'm not loading my R graph again. So how to animate this? How to animate this value basically? What I'm going to do is, on my calculate percent, I am having this minimum value which is directly getting the value from the variable. So let's delete it. And I am getting out same value from there, right? So when you add, let me show you, when you add a variable input of a float type, which is min lerp, and connect it to your minimum value, every output of the function becomes the input when you put it in the graph. So you see what happened? We have minimum lerp value here. So disconnect it, and I need to put it, sorry, I need to put it right there, exactly right there, and connect it, connect it, and that's it. Your bar graph is ready. Okay, make it bigger. You can see it easily. I would like to set it somewhere right here, maybe right there. Okay, so 100%. Sorry, what I put? Oh no, 100%. So here we go. You have accurate input, maximum, minimum, your icon print realistically on top or side or what wherever you want, and you have accurate percentage here. The one thing that I want to show you, it's a bonus thing. It's the last thing. Maybe I just give you an overview. You can do it by yourself also. So what we have when the bar is scaled like this, maybe it is something like green, and when it's scaled up, it becomes red dynamically. It changes its color dynamically. What I am going to do is very basic, very simple, something like this. Hmm. Okay, I have my material reference here, you see, and I already have a parameter which is base color in my instance material. So we'll set vector parameter value for what? For bar color, sorry, B capital COLOR, for bar color. And now you know the color value starts from the 0 and the final value will be 1 for any color, R, G, or B. So what I'm going to do is something, another map range clamp. And you need to play with this a bit. I don't know, maybe I will put this to somewhere right there, and my maybe this value right here, and the maximum scale value right there, I don't know. And you need to take out lerp linear color. What color you want to lerp with, it's up to you. Maybe the B color will be a brighter green, and I'm happy with that. So let's connect it, and I don't know it works or not, but it is the right process to lerp between two colors, and you can do it by yourself. Let's have it somewhere right. Open my graph. Let's play with the maximum value first, which is 15,000, and the bar scale is to show. Oh, it's working. And if I have the percentage like 50%, what it shows me like uh, something like this. And if I have something like very poor performance, like 450, 50 or something, it worked like this, or vice versa. Sorry. Okay. Yeah, it's great. It works. And you can implement the same logic with any kind of graph. There are few drawbacks, right? And one is the texture scale. One is the scaling texture that you can see that it's stretch. There is always some solution of these kind of stuff in the material. I will show you. I'm working on a material and you can find it on the forums, or and it works well with the tile textures. I just create a material like maybe something like this. Yeah, it is scaled with my cube, you see, but it need to be tile texture, and it has very simple, sorry, very simple logic here. I'm just getting the object scale and multiply it with the u and v's of the texture. That's it. Nothing else. So if your geometry is a basic geometry, some simple geometry like this, you can always use the scaling method. Otherwise, you have another way of doing things, which is this, right? Something like this. So it's up to you. The logic remains same. Map clamped range should be there, lerp should be there, timeline will be there, and everything remains same except a few change of logic, and that's it. This is the first part of the bar graph that we are going to conclude. And let me stop sharing. And what we have in the next webinar is something like you can see on my back on the screen. It is something that you are not limited with the numbers of graph, right? 1, 2, 3, 4, maybe 50. And also you can change their spline because they are on the path. You can dynamically change their path also. Maybe you want all of your graphs in curve, maybe in a straight line or whatever. And you have uh, full control over all the aspects of your graph. So it's a next step. We will continue in the next webinar right from there, and I will take you to the next journey, and which is like multiple dynamic bar graph on spline, and all of them carries their equal their individual values and everything. So thank you guys.